Okay, record. And let's see, I need to bring this note. And hold on, let me get the share screen here. And last class, we are getting close to complete note 2, okay? So there's a little bit more in note 2, so we are going to finish it today here first. So over here, if you took a look this cell, and over here, this square brackets. So who still remembers what the square brackets tells us in Python? Who still remember this?
That you have a list.
Yeah, very good. Okay, so this is a list, is it? And then over here, we have the it function, okay? And this it function, like over here, says it returns an iterator object. So in Python. And then if you want to get every one item, etc., you can just call next. This is kind of like if you learn Java, is it Java also have iterator, is it has next, is it, it's kind of like that, okay? But anyway, so in Python, you can call it, is it, and following a collection, pass in a collection, and it returns an iterator object here, okay? But in Java, it's an interface, is it? But you need to create the concrete iterator class. But over here in Python, it says it returns, where is the, hold on, okay, let me first start, there's some, oh, okay. And so anyway, so this method returns an iterator, and the iterator, though, we all know it's just do iterations. It's within a collection, so it's one item after next time. You can do traversing, is it visit every one by one. So here, then you can use next to always get the next item. So here is regarding iterator, and what next one try to show here is over here, we define a function, and you just be careful, okay? It's in Python, the block, we don't have braces, okay? We use colon and use indentation, okay, to identify block. And over here, and I remember last class, we already explained, is this for input, and then you convert to numbers, because whatever input is a string. And then over here, you may see this, we have some new things. So this is just a regular condition check, is it? But here that's some raise, some exception. So this is also like in other programming language, you may see a lot of try catch, is it a throw statement, is it? So similar like that. So in Python, it's called raise exception, okay? And you give some message information about this exception. So if it is, then it will raise that exception. So it won't go to. So the execution will stop here. And following this one, then over here, if you take a look, so we have that try, kind of like a try catch block. So here it's try except, is it a block? In Python, it's called try except. So under the try block, then you call this function, okay? And also, if you take a close look for Python function allows to return multiple items, okay? This is also kind of different because in other programming language, generally speaking, is if you want to return multiple items, then you need to make like an array or some collection. Hold on, let me allow them to enter. But in Python, you can return multiple items and also these multiple items. So it's much more flexible because they don't need to be in the same type. Is it? Because if you use an array like in other programming language or even like a list, linked list, some other data structure, then they all got to be the same type. But you can see over here, it's much more flexible. You can return multiple items, okay, within the function. So that's why over here you call it, you will get the two numbers, is it? You entered. And here it's to try to catch the exception, is it? And here we call it except in Python, okay? And over here, this will tell you the exception type, is it? And later on, we will see if we change to this exception that we raised, then we will see different result. And if everything, hold on, why the? Let me just admit. Then I need to re-annotation. Okay, and then if there is no exception, then you can go to the no error. So that's what this function and how to call this function to different scenario. Okay, so we can try to run with this current setup. And I can enter a number like 100, and then I enter 0. Because if it is 0, it's supposed to go to here. So let's see. Oh. I got it. I got that statement. Hold on, okay. Let me. It's trying to get the exception. Hold on, okay. Let me stop share a little bit, okay. Let me get that one back. Hold on. How about I move on to the next, and then I will come back later, okay. Okay, let's move on to the next one. Don't get stuck there. And for this it go to note 3. For why it keeps. Okay, go to note 3. So here we have a new data structure needed to discuss. So if you take a look at the first line over here, we have another, hold on, okay. This and it's, oh, hold on, I need to get rid of that and then start, because it's keep re-entering and it's mess up with the annotation. Okay, so for this note 3, so is everyone on note 3? Can you see note 3? Am I on the right note? Everybody, you can see this note 3? Note 03?
Yes.
Okay, okay, good. Okay, so let's see. So over here, if you take a look, we get the parentheses, is it? And within the parentheses, we have numbers separated with comma. Okay, so this is a new data structure. It's called a tuple. Okay, and previously what we learned is something like this, is it? And over for this one, we call it a list. And in Python, list is mutable. So later on, we will also see. So you can change it, okay? And here we have 100, 200, and 300 in parentheses. So this is a tuple. But be very careful, it's immutable. It's immutable, okay? So T1 is a tuple. And then over here, and with this index, is it? So this is called indexing. in Python. So indexing is you get a single item. Okay, so we get what? Get the first one. Hold on, I needed to close the annotation, readmit, and then restart annotation. Okay, so this is you get the first item, so you will get 100. Okay, and then next, let's see. The next one over here, it's a little bit different. Is it within other program that we didn't see this? Is it? So you have within the brackets, you have colon and following the number. Okay, so this in Python, so you have the starting index, and then colon and ending index. Okay, so this kind of structure, so it's regarding any collection. So we already learned list and the tuple. Is it? And this is called slicing in Python. Okay, it's quite useful because later on in our later discussions, we will also see this a lot. Okay, so try to get used to this concept. Indexing and slicing. Slicing is to get multiple items. Okay, then in this case, but to be careful, this last index is not included. Not included. So what you will get in this case, and it didn't specify, hold on, okay, I needed to keep having student coming in. I need to read, I always needed to close the annotation. And we got that. So this index specify item is not included. So and we didn't specify the starting one. So that means starting from 0 and including sub 1 and sub 0 and sub 1. So you will get 100 and 200. Yeah. Someone, can you turn off your, can you mute your audio? Can you mute your audio? And just keep that in mind, tuple is not like a list, it's immutable. Okay, immutable, that means you cannot do something like this. So you cannot reassign. So once you defined, so you cannot change it. Okay, you cannot change. So it will get error if you try to do something like that. Okay, so that's about immutable concept. And then let's take a look over here. So on the right side is the tuple, is it? On the left side, we have 3 variables. Okay, 3 variables. So in this case, we call it unpacking. So 1 will get 100. Variable 2 will get 200, and 3 will get 300. That's how this works. Okay, so it's called unpacking. Okay, it's also quite useful. And over here, the example show using unpacking, you can also convenient do swapping. Okay, it's not like other program you need to have 3 statements, is it? So here you just have a single line, is it? Then it can do swapping, is it? Okay, so then next, let's take a look at this case. So T2. T2 is a tuple, is it from 1, 2, 3, 4, it have 5 numbers. And then let's see this kind of unpacking. So the third one, for the third variable ahead of it, it has a asterisk, is it? So what does this asterisk do? Asterisk is that absorb any number that's not matching the other, because in this case, so you have 100, so A will match 100, B will match 200. So whatever left over, so C basically in this case will be what? We'll get multiple values. Will get hold on, I need to keep having. Please mute your audio. So C will get off the leftover, 300, 500, 600. Okay, so that's how the unpacking. And if you have this asterisk, okay, ahead of, and later on we will also see, like in functions, sometimes you also have something like this, like arc. Is it? So it's kind of the concept like this, if you are used to that kind of idea. Please mute your audio. And the question mark we already learned. Is it? And that this asterisk got to be always the last. You can also put it in the middle in this case. Is it? In this case, A will get 100 and C will get 600. And then B will get the middle part. Okay, so anywhere it's not matching the other one, then it will catch all of those. So that's regarding the tuple. And next, what I show is list and the tuple can also convert back and forth. Is it T2 is a tuple, and if you have list, basically over here this call, this is constructor, is a list is constructor. Is it? And you plug in with a tuple, is it? Then you will get a list. Okay, and similar. If you have a list, then you plug in with the constructor of tuple, you get a tuple. Okay, so that's what over here the result shows. Okay, we understand this part. And next, next one, let's take a look here. Be careful, okay. So we already know slicing, is it? So slicing, we already said like the colon, is it? And starting index, ending index. And over here, you see you have 2 colon, is it? So basically the second one, after that means the step. So how many like every other, is it kind of? Okay, so this is step. So in this case, you specify the starting index, but ending one, ending index, it's didn't specify, is it? So it's kind of go with default. So default always the end for the ending, is it? But the step is, so if you don't specify step like the previously we showed, then that means the default one is 1, okay? And over here you said, okay, why I want to every 2, is it? Then you can specify as 2 or every 3, is it? So then in this case, start here, bar, is it? And then get over the other one, the next one, so it's every 2, is it? Every 2, and then same thing, is it? Get every 2, so it's all the way to the end, okay? So that's for the slicing. And then next, let's take a look at this case. And this is also interesting, is it? Because in other programming language, you never see negative index number, is it? But in Python, it's allowed, but it has some special meaning, okay, special meaning. So this negative is for the step. Is it? If it's for step, that means you want to do the reversing, okay? You want start from the first to the end, is it? But it's kind of count from the end to the beginning, is it? So that's why it's do reversing, okay? So basically, if you want to reverse a collection, you can also kind of using this idea, is it? Okay, then next, let's take a look at list. Previously, we kind of just a very quick glimpse of list. So let's see here, this list. If you take a close look, is it? And also in Python, not like other programming language. For this list, we have number, we also have string, is it? In one list. So this is legal in Python. And then the third item in this list is another list. So it's embedded another list. Okay, so be very careful here. This is legal, okay? And list, and the list allows you to grow and shrink, okay? So you can add and you can remove. So list is mutable. It allows you to change, okay? And whatever within the list is called some objects, okay, object. So let's see what, so if you just do print, then it will give you the whole list, is it? And the length, how many? It's 3 in this case, because first item, second item, third item, okay? And this is what? This is index, is it? So it will get the second item. But here, be careful. Over here, we use negative indexing, is it? So this means what? This means the last item. Okay, so count from the last. So it's -1. And then in this case, what will be the second last? Then it's going to be, so this represents second last. Second last, okay, so it will be what? It will be 2, okay, so you can use negative, okay. And then next, let's see. And over here, you can also do slicing using negative. So this means to the last, is it? But be careful here, okay, the difference. If you do x0, you didn't specify, that's including the last, okay. And here you said -1, so that means the last one not included. Okay, so be careful about this. And for list, then this is legal. Because what? Because list is mutable. Okay, so this is fine. And then next, let's see. So there are a lot of usage for the slicing. If we take a look here, we still regarding this list X, is it? And where it start? It start at the very last, is it? Length X. And all the way to where it didn't specify. Generally speaking, and for array, you cannot do this, okay? But Python, we don't have array for Python, okay? And generally, I just mean generally just about Python, okay? Not NumPy. Later on, what we will learn, okay? So here regarding generally Python programming language, and here it's all the way to the end. That means, but there is no end. You already started from the end, is it? Then what does this mean? Basically, this means you append a list. So you can expansion a list, also do something like this, okay, using slicing, is it? So you can also then add at the beginning, add another list, is it? So you can say it's very powerful. You can also do remove part of your list, is it? Then you just set the range and then you just let it be an empty, is it? So then it will remove, okay? So here just introduce us multiple ways. You can do appending at the beginning, at the end, and even including removing, okay? And next, let's see the append method. And here we use the dot, okay? So that means this append method belongs to list, okay? So it's a member function. So the append, be careful, append means append a single item at the back of the list, okay? And in Python, for list, there is another function called extend. And extend, what you need to plug in is what? Is a list, okay? So you add at the back of the list. And you can also do insert. So specify where you want to insert an item, okay? So those, be careful. Those 3 methods are part of list. Part of list, okay? Part of list objects. Next, let's say it's different, okay. And you can also call, if you want to delete something, you can also just call del, okay. But del is just a general function, general method, kind of like command, is it? So then you can remove single item. And you can also remove multiple items using slicing, okay, using slicing. And that's not the only way you can remove items. You can also, so list itself also has remove method. And be careful when you call del, there is no parentheses, okay? So this is considered as a command, okay? But this remove, you have parentheses, okay? Be careful, but this remove is a method, okay? So what it, and over here, you need to tell which position is it you want to remove. And over here, what you do is you find the item first. Find first, then you remove. Okay, so not using index in this case. And the next one try to show is reverse. You can also explicitly call the reverse function. And previously for using slicing, using negative indexing, is that you can also achieve the same goal for reversing. As here just show, you can also call the method. And the sort method. So list, you can also do sort. So call list sort. And what next also is interesting over here is here we define a function called compare number of characters, and you pass in a string, is it? And it's just very simple, just return the length of the string, okay? And then over here, we have a word list. So this is a list, okay? Within the list, you have 5 single word, is it? And you can call the list dot sort, is it? So over here, this y is a number list. So when you call sort, so we all know then you can sort by the nature order, is it? And here sort for string, is it? So string by default, the nature ordering is what? Is lexicography. Okay, so it's by like A, B, C, D, E, like this, is it? So that's default sorting, is it? And a lot of times, you don't want just to do sort by the default nature ordering, is it? You want to have some user defined ordering, is it? And then in Python, you are also allowed to do that. Then you just specify with key. And over here, you specify, you remember that is a function. This is a function. And that function returns the length, is it? Return length of a string, is it? So over here, you said, oh, I want to compare by the length of the string. Then what you can do is you just specify the approach you want to do the sorting, is it? And if you recall in Java, is it? It's kind of like you can define the comparator, is it? So this concept, I personally think, okay, it's kind of like Java's comparator, is it? You define your own comparing criteria, okay? Not based on its nature ordering, okay? Okay, and then next one it shows for sort. It also allows you to do reverse ordering, is it descent ordering? Then you can do reverse, set it as true. Okay, set it as true. So that's regarding sort, but this function for sort is belong to list. Next is a tuple, is it? And we can also do sort. And you can also call sorted. So this is general, okay? It's not lists or tuples method. And another one to check membership in a list or in a tuple is anyway in some collections, you can do this in or not in. This is used to check membership. And next one I try to show is if you recall, and over here, Y is a list, Z1 is also a list. That Z1 is a Z1 is a list. That because sorted, so Z is a tuple, but sorted is a return a list. Okay, so Z1 is a list, Y is a list. Is it? So you can, if you use this arithmetic operator plus, this means it's want to concatenation, list concatenation. Is it? And I don't know if anyone still remember the other way with a list function. You can also achieve this concatenation to do concatenation. Who remembers what that function's name? Who remembers that function's name for list? So over here, Z2 is Y concatenate with Z1. Is it both Y and Z1 a list? Is it lists? Is it? And Y is a list. You can call some method, some function to also achieve the same goal. Who remembers? That method is extend. Okay, so keep that in mind. You can also do that. And there's some other way, remember, for list itself. Is it? You can do slicing. Is it? You can also do slicing. Is it? And do the concatenation, slicing to achieve concatenation. So there are multiple ways, okay? And then let's see this one. This is also weird, is it? Because in other programming language, if you do something like this multiplication, okay, but in Python, you can also apply this multiplication operator, okay, following by a number. So this just means repetition. Okay, so you want to repeat this specific item 3 times. Okay, so that's what this means. So basically, kind of you expand the Y list 3 times longer. Okay. And in Python, if you want to get to the maximum and the minimum item, there's a function to achieve that called max and the minima. Okay, and you can also, if you want to do the search and get the specific index of the item within a collection, you can just call the index method. Okay, append we already learned. You can also do count. Okay, so those are just some method related with collection. Okay, so that's regarding more information regarding list. And all of this above discussion quite useful because later on when we discuss NumPy and the pandas, we are going to use some of the concepts here. Okay, so if we can get it familiar here, it will be simpler for us for later on. So next, let's see, multi-dimensional list. And because we don't have array, etc., so you can do multi-dimensional, if you want to represent some multi-dimensional data, is it? So you can use multi-dimensional list. How do we do that? So here it shows. So this is the outer kind of outer list, is it? And this is the inner, so nested list. Nested list. So if you do m sub 0, it will return what? it will return you a list. Okay, so that's what it returns. So the return type is a list, And then if you do this, so this part return you a list. That's why you can continue do indexing, is it? So this is a second level then, okay. So then this will give you 1, okay. So that's regarding multi-dimensional list. And then next, let's see, because list is mutable, so we need to be careful about shallow copy and deep copy issue, okay? So let's see. So here you have a nested. So this is a list, and this is original. What original build is? So this is a hierarchical data type. Is it because over here you have single scalar, and this one is a list, okay? But this is allowed in Python, is it? And then over here it shows nested. So nested changed in this case, is it changed to -101, is it? And so my question is, if I do original, is it? If I do original, then sub-0, what will you get? Will you get like 0, 1, or will you get -101? You will get -100, okay. So you will get what? You will get, in this case, you will get -101. So that's what you will get, okay. So this is called what? This is called shallow copy, okay, shallow copy. And then same thing here. So you need to be very careful, okay. Even though you said I changed it here, is it? I didn't change, go to original change, but because you change nested, it also impact original, okay, impact original. That's because the nested, so that 0, 1 is in this memory block, is it? And then it's part of your original, is it? So original, then you have 100, 200, and 300, is it? So you change -100 still in that same memory block, is it? So that's why it's also impact the original, is it? Even though, because this is nested. So this memory block identified by this nested name, is it? And here you have original, identify this block name. And then let's see, original 0, sub-0, and sub-1, is it? So what is that? Sub-0, sub-1, it should be this item, is it? So it's going to change this item to what? To -100. So will nested be changed? Of course, because it does change here. So this is a concept we call what? We call shallow copy. Okay, shallow copy. So be very careful here, okay? And then next, let's see. Next, okay, so here is a good idea. Okay, so original, then let's just assume we still use this nested. Okay, so we have a 0 and 1, is it? And then we have 100, 200, and 300. Okay, and then this is identified by nested. Okay, and this identified by original, is it? Okay, now I said nested equals 51, 52, 53. So here, the question is, where is this going to happen? Is this going to happen here? Be careful, okay? Be careful, okay? So over here, okay, over here, what it means, because once you do something like this, basically this nested will point to here, 51, 52, and 53. It's repoint to there. Okay, so if you print out original, it won't impact original. Original will be still like that, but nested will point to a new location, because this is like you create a new list. When you create a new list, it's go to a different memory location. Okay, so it's at a new location. So nested will not point to this anymore. Okay, so it's changed to point at a different location. Okay, so be very careful here. And next, what I try to show here is that slicing basically is shallow copy. Okay, so if you have a shallow, you said you do some slicing on the original. Basically, this get everything in the original. Okay, and then in this case, if you do something like this, so this is our original. Original, we have this 0 and 1. Then you have 100, 200, and 300. Is it? So this is original. And then you said, okay, I take a part of this original, I do slicing, and basically this shallow also going to point to this memory block. Okay, and if you set 0, 0, sub-0, sub-0, so it's going to be this one. So this one will be changed to 0. Okay, change it to 0. And if you print original, even though you didn't explicitly do everything original, but it will also change original. So be very careful, okay, when you do slicing, after you do slicing. If you said, okay, that's not my intention, okay, my intention is to do the modification on the copy, then you need to do the deep copy. Okay, you see just copy, is it you import copy package, and then you call it deep copy function. You plug in original. Then what this is going to happen, so this is, so it will explicitly create. So this is going to be copy. Okay, so it will have that 0, 1. Is it? And then have 100, 200, and 300. Okay, and then later on you said, okay, this this is called deep copy. This is a deep, is it? And then you said, okay, for the deep, I said it's deep 0. So over here, this is going to be changed to deep 0. But will it impact the original? No, okay, because this conducts so the dot copy will, that deep copy. That deep copy, okay. So it will create a clone, okay, a completely a clone with the same content but at different memory location, so that you change something like here, it won't impact the original, okay. So make sure those subtle trick here. And previously, if you recall, we discussed the extent, is it? You can do concatenate, you can also use plus, is it? So generally speaking, list, if you have a lot larger items, this is preferable, okay, because this is more efficient, like over here says, faster, okay. So that's just some side thing. Okay, then let's see, we kind of, over here, so we learned the square brackets, parentheses. So if you take a look here, we have a new thing. Okay, this in Python, it's not about blocking. Okay, so this means map, a new kind of data structure. Map is key value pair. Key value pair. Okay. In if you learn Java, it's also called map. And in some other language like C#, I remember it's called dictionary or associate array in C++, I believe. Okay, so anyway, so over here, key value pair, okay, key value pair. So then key value pair, we use bracket. So this means it's an empty map you created, is it? And for map, how do you add items? And in Python, there's another quite useful function called enumerate. Okay, what is enumerate? Returns. It's an enumerate function returns a sequence of a tuple, and it with enumerate, you kind of try to count, is it? Okay, so I means the counting number 0, 1, 2, 3, 4, 5, something, is it? And this is whatever the value from the collection, is it? So this is a list, a collection. And if you do enumerate, so I will be the number, is it? 1, 2, 3, 4, 5. And the V is what? Is the item you get from the list. And here is what? Here is a string. Is it corresponding to the each string? So in this case, your key for the map is a string. And in Python, it's just str, is it? And the value is what? Is integer number. Is it integer number? Okay, so the key value pair, okay. And what does the key value pair look like? So it will look like foo is 1, bar 2, and baz 3. Okay, something. So you can explicitly assign the key value pair to the map, okay, item by item. So that's one way, okay? But you first need to create the map object. And what next try to show is there is a quite useful method called zip method, okay? So what a zip method, it pairs up, okay, from some collection. So here we have 2 lists, is a sequence 1, sequence 2, and then you call zip. And what do you get? You get an iterator object. Okay, and this iterator object is a tuple. Okay, a tuple. So basically it's going to have foo and pair together and 1. Is it a tuple and then bar pair with 2. So pair together, okay. But iterator object, it's not a conglomerate collection, okay. So you need to use next to get the next item. It, generally speaking, it tells you where the first is it? So you get next. So in order you get the whole objects, the conglomeration of all of the items. That's why if you want to read them, you add the list to the iterator. So that's a iterator object. So over here, you plug in with an iterator object. So basically, you are going to have a list of tuples in this case, okay? So that's baz and 3. But they pair together with this zip function, okay? So that's how the zip works. And then next, let's see. And here, zip doesn't just apply to sequence, okay? We have sequence 3, as it just have 2 items. So you can also have 3 collection and call zip. And then in this case, then you may ask, they are not the same length. what's going to happen? So they will take by the shortest sequence. So you will only have two tuples. Okay, and when we call the list, but you have 3 items. Okay, so 3 items here paired together. That's how this, but it will take the shortest sequence. Okay, so that's what this part means. And then same thing over here. You can do enumerate and you can zip. Okay, because zip returns iterator, is it? So then you can get the tuples, is it? In this case, A and B. Okay, so that's what this part means. And what the last one try to show us is with the asterisk operator. Okay, so the asterisk is can do unpacking. Is it like what we explained before? So this pictures is what? Is a list of tuple. Tuple, is it? Is a list of tuple. And then you apply the asterisk and then you call the zip, is it? And then it can do what? Can do unpacking. Okay, can do unpacking is what? So you will get this two, basically, first name is going to be sequence consist of the first one. And then the last name going to compare, consists of the last name part. So then you will have these two different sequences because you unpack them, because initially they are in the tuple, okay? So that's what asterisk and zip together, okay? Oh, I'm sorry, I got the name wrong, okay? Completely messed me up. So in Python, it's called dictionary. I'm sorry. So what the curly brackets? The curly bracket in Python is called dictionary. And in Java, it's called map, okay? So anyway, so dictionary identified by the colon, okay, by the colon. So key and value, okay? So key value pair. Okay, so over here it's a empty dictionary, okay? And after you create the empty dictionary object, and you specify the key and assign value, okay? So key, so you can retrieve value with the corresponding key. So this is kind of the concept like a phone book, okay? So, or yeah, because the name is quite clear, called dictionary. The dictionary is a word, and then you find its explanation, etc. So that's why over here it's called dictionary, and in Java, yeah, it's called map. And so here we keep filling this dictionary as a dictionary. And if you use the key, is it with the square brackets you specify here, then you get value. So this will give the value part. Okay. And here is one way you initiate a dictionary, okay, initiate dictionary. And there is another way you can directly fill the brackets with a key value pair separated by comma, okay. Within comma, you have colon. Okay, so here colon used for key value pair, key and value. Okay, key value. And we kind of run out of time, so we didn't get time to complete note 3. So we will continue to finish note 3 next Monday, okay? And any other questions before we dismiss today's class? Any other questions? And if there is no questions, so I will see you all next Monday. Bye.